So here's what Desmos 3D looks like. You can move all this around. Now, this is the equation that I gave you in 3 space. There's this coordinate here. See the dot right there? Now, I could have not told you that. I could have just said f of 2 comma negative 3, and it would have provided that for you. Just kind of like there's an x, f of x. It's the same kind of thing. So there's your dot. So for partial derivatives, you might see this notation. When you're finding the partial with respect to x, then you pretend that your y's are constants. And when you take the partial with respect to y, then you pretend that the x's are constants. You also might see this notation. Since I know my x and y, I'm going to plug them in and get a number for each of my partials. Since I know what they are, I shouldn't call them x and y anymore. I should be calling them a and b. I'm switching back to that other notation, but you're Calc 3, so you're fine. Note that this is how we're going to find the equation of the tangent plane. Consider that this is really just a variation on a theme. In Calc 3, we have the 3D version, but it's reminiscent of, in Calc 1, you had the 2D version. Note where your derivatives go and how much space between the variable you have and that constant that you evaluate. They're all roughly in the same spots. We just get an extra dimension when we're in Calc 3. And notice how when you're in Calc 1, that was really just a variation on a theme of something you did in algebra. So let's put all of these things together and look at that beautiful tangent plane. Look how nice it is. It goes right through there, see? This nice little slice. Beautiful. Right through that point that we defined earlier. I hope this makes you as happy as it makes me. There it is. Calc 3 is beautiful.